Hey everyone, welcome to Code Harmony. Today we will be solving LeetCode problem ID 2337. Move pieces to obtain a string. This is a good two-pointer based question and recently it has been asked by Google and Amazon. Let's have a look on the problem statement. Let me show you by example. Here we are given two strings, start and end, and both the strings are of length n, and these strings can only contain character like L, R and underscore, only these characters as also given in the constraints. L, R and underscore, both the string are of same length and goes till 10 power 5. Okay, now what we have to do is we need to tell them whether we are able to achieve target from start or not. We have to convert start to target by doing some operation, and after doing that operation, if we are able to convert the start to target, we are going to return true, otherwise return false. Now what are those operations? The start can have three kind of characters only, underscore, R and L. If it is L, then we have the option to move that character to the left side any number of time if there is underscore. And if the character in the start is R, then we have the permission to move that character to the right side any number of time if we are having underscore. So this L character can move to left side and this R character can move to right side, but this L cannot move on the right side, right? So this L means move to the left any number of time if it is a empty space or underscore. If it is R, move to the right any number of time if it is empty space. Now after doing couple of operations, do this operation any number of time. If you are able to convert it to the target, then return true, otherwise return false. So this was the problem statement. Now how can we approach this problem? Here we see that these L, R, these are the characters from start string and these can be arranged accordingly. But when I do the arrangement, let's say this L is moved to the left side, this R is moved to the right side, then moved to the right side. But here, will it be moved to this R? No, because these characters are not crossing each other. Only if there is an empty space, we can move the character. Okay, so from this condition, what I'm getting is that these character order will be preserved in the final arrangement. So even if we do the arrangement, if I move L to the left side, it will become L underscore 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 right underscore underscore right underscore. So this arrangement. So whatever is the arrangement, these character order is preserved. So this L, R, R will remain same. And if L, R, R remain same, I will be able to convert it to any possible combination. Just keeping in mind that we have one special condition that L can move only to the left side and R can move only to the right side. If I tell you that you can move any direction, like move L to the right side, left side, do whatever you want, then you will be able to get to the final state by definitely some number of operations. So for now, let's not just consider that L can only move to the left side, R can only move to the right side. Okay, we are free to move these characters, and then we will be definitely able to come to this arrangement, keeping in mind that this target should have the characters in the same order as of the start, because we are not crossing any character. So in the start, the character order was L, R, R. In the target, the character order is also L, R, R. It means we are able to achieve it if we are free to move in any direction. Okay. Later on, we will add one more condition that the L can only move to the left side, R can only move to the right side. So what we will check is we can go pointer by pointer in both the string. Let's say for the start, I'm having I pointer. For the target, I'm having J pointer. I need to convert start to target. So what I will do is I will see what are the possible values at I and J. And if I tell you at index I and J, we can have limited number of options. Let's say this is from start and this is for target. Both the character can be empty space. If both the character are empty space, I am going to increment my I pointer, increment my J pointer. This is the first condition. What can be the second condition? This is empty and this is some character. If the first is empty character, my tendency would be to move to any non-empty character first. Then I will compare the values. So first of all, my aim is to come to the first non-empty character, non-empty character from target. Then I will compare the values. The start is empty and target is a character. It means I need to increment my start pointer. Or it can be other way around, that start is having some character and the target is having some empty character. In that case, my target will be incremented. What is the fourth combination? Both are empty, one is empty, or nobody is empty. If nobody is empty, then we have some possibilities. If both the characters are same, it means we are good with that specific character and we can increment our pointer I++, j++. If you look on these conditions, these first three conditions are fine, and this fourth condition, we have not utilized that logic that L can only move to the left side. Let's say the conditions were something like this: L underscore underscore and underscore L underscore, and this is my source and this is my target. Will I be able to achieve my target from my source? This L can move only to the left direction, so we are not able to move it to the right. It will be false. So we need to see that if it is an L in the starting, so its pointer should be more than the pointer in the target. So here I pointer is having L and J pointer is having L. So this L can be shifted to left because J is less than equal to I. J is on the left side. If we require the L character on the left side, we can do that. If we require R character on the right side, we can do that. The opposite is not true. So if both the characters are same, if character is L, then the pointer in the source string I should be greater than equal to J. Okay. So this is main condition we have to keep track of. Let's say after some time, my I pointer is at this and my J pointer is at this. Because whenever we are at non-empty spaces, we will do something. I is coming here, J is coming here. Now we will see, can I move, both of these are same. First of all, these are same, and then we will check whether this I can be converted to J. This I pointer, after 2 position, we are coming to J. This I pointer is less than equal to J. It means this R can easily be moved to the right side because we are having some spaces. Or if this R coming between, I will just shift that as well. Okay. So this pointer, this I pointer is less than equal to J pointer and we are encountering R, then it is fine. If it was something like this, underscore underscore R and R underscore underscore, this is my source, this is my target. In this case, it is false because I is equal to 2 and J is equal to 0. 2 cannot be moved to 0. 2 can be incremented. I hope you are getting what I am saying. This I pointer, if it is R, it will only move to the right direction. If it is L, it will only move to the left direction. So when these characters are same, we have a couple of conditions. If character is equal to L, we will check if this is the combination of our indices. If character is R, in that case, I should be less than equal to J. Okay, I think only these two conditions are there. If this is the case, we can move ahead. It means we can make these two characters on the same position. And what is my last condition? If those characters are not same. If those are not same, just directly return false, because the order of these characters are preserved. Okay, yeah, this much we have to do. Like we are doing 2 pointers, I for my starting and J for my target, and we'll just compare those values. If both the values are space, just increment it. If one is space, just increment that specific one, because I want both the pointers to be either on L, either on R. Now if they are on non-empty spaces, if both the characters are same, then we will check whether we can convert the S character or move the S character to the target position. Like this. And in the end, there might be the possibility that, okay, my I pointer is on the left index and J pointer has moved out of the bound. what I'm trying to say is that there might be possibility that it was something like this. The source is this and target is, let's say initially I started at I equal to 0, j equal to empty spaces. If it is empty, I will move my j to this position. I and j are same and I can be converted to j. So I will increment by I value, I increment by j value. And now as both the characters are empty, it will be incremented one by one. I here, j here, I here, j here, I here, j at this position. So j will breaking the loop. J is breaking the loop because both the indices should be valid. If j is breaking the loop, I also need to move my I pointer out of this string. So if I am able to get my I pointer and j pointer or respective length n and m, in that case I can return true. Otherwise, for false condition, it will be returning from the iteration from the while loop. So if I am able to reach my I to n and j to m, it means that we have come out of this loop where we are comparing characters. And if this loop is not returning false, it is definitely true. Or you can say it is if I equal to n and j equal to m. Okay. So what I did is I just 2 pointers. What can be the time complexity in this case? I move 2 pointer I and j, I for my start and j for my target. But time complexity would be I plus j, because I am iterating every single character in both of these string only once. And what is the space complexity? Space complexity is we are not taking any extra space. We are just using iterations. Okay. So this was the time and space complexity. Now we'll quickly code this approach and I will be doing the same implementation. While I is less than n, j is less than m, if both are spaces, if any one is empty and nobody is empty. First of all, I will take 2 pointers I and j, and then I will capture the length n for start, m for my target. And while I am having a valid index, I is less than n and j is less than m. Now I need to check these characters. Let's say character A is from the start and character B is from target. Now I need to add conditions. If character A is equal to empty space and character B is equal to empty space. If both are empty space, I will increment both the pointers. Else if A is empty space, it means A is empty and B is not empty. In that case, I will increment I. Else if B is empty space, in that case I will increment the B pointer. And now comes the important case. Else if both the characters are same, A equal to B, but when both the characters are same, I need to see whether I'm able to make A equal to B. If A is equal to let's say L, in that case I can only move my I pointer to left side if it is required. If I is already on the left side, I can make it to right. It means that I should be greater than equal to J. Either this is the case, or if let's say A is equal to R, it means I can move A to right side only. So it should be left side initially. I less than equal to J. Only in this case I can convert my start to target. It means these combinations are valid. I have L in the start and in the target, and they can be arranged to the specific value. Now it's time to skip these character set and I will move further. And what if I'm not having these two characters same? In that case, I will directly return false. No need to move further. In the end, what you have to return is, I try to return true. Let's check over sample test cases. Otherwise, I might have to add one more condition, because we are not checking those cases where number of non-empty character are not same. If I try to submit, I think it should fail. Wrong answer. It is going to give me wrong answer when these L R count is not same. So for that, what I have to do is I need to process the remaining characters as well. So when you are coming out of the loop, you also need to finish that string. So while I is less than n and start dot character at I is equal to empty character. It should only be empty character, and just increment I, and do the same thing for j as well. J is less than m. Now it's instead of start, do the target dot character at j equal to empty character. In that case, I'm going to increment j. Now after this operation, if I is becoming equal to n and j is becoming equal to m, it means we are able to process the complete start string. Let's try to run again. This time it should pass. It worked fine. Okay, I hope you understood the approach. In case you have any doubt, you can comment down below. Thank you guys. Bye bye.